Welcome to a tutorial series for Reexpress 1. Reexpress is a paradigm-shifting approach for data analysis and analyzing neural networks that saves you time with a no-code environment, reduces your costs by avoiding cloud spending, and preserves your privacy by keeping your data directly on your Mac. Kicking off our tutorial series, today we're going to look at the core functionality of Reexpress 1 for document classification and semantic search. We'll be doing this through the lens of binary sentiment classification. To make sure everyone's on the same page, here are two examples that demonstrate what the input JSON lines file looks like. This consists of a unique ID, a label, which is an integer between 0 and 1, corresponding to negative and positive, and the document text itself, which is taken as input to the on-device model. Okay, let's jump right in and create a new project. Binary classification, two classes. Let's choose the 1 billion parameter model. We do need a prompt in this case. We can just choose the sentiment and product review. Continue. Let's choose a directory and file name. Let's call this sentiment tutorial. And we can save and then create a new project. Okay, so next up we'll want to add our data. We add data via straightforward JSON lines format where each line is a valid JSON object with at least the three required fields of ID, label, and document. We can click Save an Example Template at the top here to disk for a starter file for reference. We can click Details for additional info on each of the fields. And there's also starter code for formatting your data via the links below in both Python and Swift. Now, once you've formatted your data, no additional programming will be needed as Reexpress 1 handles the heavy lifting for you. So all the data analysis is done via the no-code environment. Okay, so for the tutorial here, we've already formatted the data, so we'll want to upload each file to its corresponding data split. Remember, everything is on device, so when we say upload, we mean saving the file into your project file saved on your Mac's hard drive. Let's do this one by one to see what this looks like. Okay, so we'll also have the training set and then also the validation set. And that looks good. Go ahead and click upload. Great. Okay, so the next step is to also add label display names. And we can just select the file, open. Great. Okay, so now we have negative and positive as the display names instead of the integers 0 and 1. Okay, so let's go to learn, start training. We can use a batch setting. And let's select all of the data splits to run the prediction step after training is complete. Check we have enough space, and then let's go ahead and kick off training. So for the purpose of this tutorial, I'm going to fast forward the video, but we'll go into additional detail on training in later tutorials. Okay, so after the parameters are cached, we'll optimize the parameters of the model, and then we'll compress the model. And then the production step includes calculating feature importance and estimating uncertainty, which itself involves a dense vector matching step. Jumping to the end, we see that training and prediction took a total of around 45 minutes. We can click Done, and we can examine the training and compression learning curves. If we aren't satisfied with something or if the data changes in the future, we can always come back to this tab, click Train, and continue either the full training process or just the compression stage. Now, another neat thing is that the program keeps track of changes to the data, so the status view here will let us know if we need to rerun training. Let's jump over to the Explore tab. So this document details navigator on the right provides the core information for each document. So in other parts of the application as well, we can pull up the standard details view to get more information about a document. So a key part of Reexpress is being able to quickly slice and dice your database in various criteria, which we can do via the select button here. We can divide the data by similarity to training, the distance to training, the magnitude of the output, and the model prediction. These signals turn out to be fundamental to deriving reliable uncertainty estimates with neural networks. So for example, we can choose the distance to training and select the similarity to training. And in future tutorials, we'll go into more detail as to how these are derived in the application. Alternatively, we can choose the overall calibration reliability. This is a second order estimate of the reliability of the calibrated probability, and we'll see more materially how this is determined. We can also go to constraints. Here we have even more fine-grained control. For example, choosing particular cutoffs for the distance and output magnitudes. We can also choose how the data is sorted. For example, if we want to sort by distance and similarity, we can choose the order of the sort, and we also have a keyword search here. And let's go to semantic search. Let's run a semantic search and then take a look at the information available at the document level. The search algorithm is pretty clever and unique to Reexpress. It's a hybrid vector and lexical search, and we can further upweight particular keywords, as we'll do here with Brana's name. So to run the search, the model runs inference on the search query and then performs the search at the document level, and also runs a search within the document to try to find the most relevant sentence or feature. An interesting takeaway is that many enterprise cases you might think of modeling via generative language model, such as via retrieval and appending to the prompt, can just be done directly here via semantic search. Okay, looking at the top return document, we see that it is indeed relevant. Highlighted in blue is the sentence with the highest feature importance relative to the predicted class, here the positive class, and highlighted in orange is the most relevant sentence for the semantic search. We see that the calibrated probability is quite high for the predicted class. We can click on calibrated probability to pull up the chart. And then additionally, we can look and see how the calibration reliability was calculated. Here it's the highest calibration reliability. We see too that the partition size and calibration that determine the calibrated probability is quite high. Generally, we want this to be above 1000, and we can further look at each of the constituent factors that determine the data partition used in calculating the probability. The similarity to training, the distance to training, and then as well as the magnitude of the output. The highlights button summarizes the visual indicators, such as those relating to feature importance and semantic search. Note too that you can turn these highlights off via the gear icon in the details view. And you can click resize here to, if you want to expand the particular view. Clicking document level, you can run a dense vector search against a particular data split. Here, running it against training set, we pull up the nearest document. We click details to get the details view for that particular document. Close, and then we can also do a similar search at the feature level. So this is pretty interesting. So you can click a particular feature in your document, and then that will be taken as the focus for the search. Here, let's do a search in the calibration, and let's only search the document text. Now, keep in mind that we trained the model with document level labels, so the feature level search is semi-supervised, but we find this can be a useful additional option in your toolkit to investigate your data. Okay, so let's close this and then take a look at what additional options we have at the details view for modifying the document itself. If you want to record that you've already viewed this particular document, you can click last viewed. You can also change, for example, the label if you click on label, and you can change the other fields as well, such as the group field or the info field. And you can also change which data split the document is in. So in this tutorial, we trained the model for binary classification, but I want to mention that Reexpress also has a re-ranking ability. If you train the model in a multitask fashion, you can run the re-ranking step on a semantic search. In some cases, this can improve the relevance rankings of your semantic search. We'll go into more details on this in a future tutorial. In the details view, I showed that you can modify your data one document at a time. If you click details, there's an option to make batch changes to all documents in a particular selection. This can be useful, for example, if you want to make bulk changes to the labels or to transfer documents to another data split. So that's the Explore tab. So now let's go to the Compare tab. In Compare, you can visually analyze your data, view summary statistics, and view side-by-side comparisons across data splits. As in the Explore tab, click Select to partition the data. Here we'll choose the highest reliability partition for the positive class, and then click Select. And note that the graphs are interactive, so you can click on a data point to pull up the details view for that particular document. So that's Compare. Next, let's go to the Discover tab. Within Discover, the Features tab lists the most prominent features for a selected class. This can be very useful when you're initially analyzing your data. Scrolling through, we see that in this case, the features do seem to align with what we would associate with positive movie reviews. The Errors tab provides the output of an algorithm for discovering possible ground truth label errors. This can save you time when you're trying to improve the quality of your data. The basic idea of the approach is to search the data for high probability predictions that do not match the ground truth labels. Manual inspection is, of course, still required to verify, but this can save you a lot of time by narrowing down the possible search space. So that's Discover. Now let's finish with a quick look at a Compose where we can predict over new documents that we manually type into the text box. First, let's select a prompt. We'll use the default prompt that we use when we were training the model. Then let's type a document into the text box. Now, if we have multiple documents, it's typically more efficient to upload via the JSON lines format, but Compose can be useful for one-off predictions. And then we'll click Predict. This will first check that the model is up to date and that the database of examples is current for calibrating the prediction. And then it will run inference over the document. The output will be saved to a temporary cache. We can save the document by going to the Details view and transferring the document to one of the existing data splits. Once the prediction is complete, we'll see the details view for the document where we can explore the prediction. And as I mentioned, we can scroll down and we can click on temporary cache to transfer to one of the existing data splits. So that's Compose. One last thing I want to mention today. I said earlier that the program keeps track of changes to the data. Let's look at that briefly in practice. Going back to Explore, let's change a label in the training set. Let's just flip this label to unlabeled. Note that immediately we'll get a warning in red here that we need to rerun prediction to make sure that the uncertainty estimates are up to date. And if we click status, we'll see a recommendation to retrain. So that's it for today. We've covered much of the core capabilities of Reexpress 1, but there's still more to explore. In our next tutorial, we'll see how you can add uncertainty quantification to essentially any generative AI language model. As always, if you have any questions, don't hesitate to contact us. Thanks.